We're going to start this worksheet off with a linear equation in standard form. I am in standard form because I match exactly what the standard form equation is for our linear equations. A is by x and b is by y, so b is -5. That's the coefficient, that's a coefficient, and they're on the same side. The constant c sits on the other side alone by itself. What I want to do is take this standard form and change it into slope-intercept form. To do that, I notice that x and y here are on the same side, but x and y here are not on the same side. So what do? You move him to the other side. You can draw your river, and then you can take 3x, who is positive, do the inverse operations. Going to subtract him. Bring down what's left. Be careful, that is a negative. You got to bring him down. And there are many ways to write this side, but because I want it to look like mx plus b, I'm going to ask you to put the x first. And he's negative, so I have to take the negative with the 3. Now 30 is positive, so I'm going to write plus 30. Always take the sign for the coefficient in front of x down with it when you move it. And this one doesn't have a sign because it's positive, so I wrote plus 30. You would write minus if this number was negative. You would write a minus sign here if 30 was negative. Now when we divide, we do not change the sign. Divide by what you see. We're dividing everything on the other side by -5. Why? He's multiplying to get rid of the -5. We do the inverse operation, which is to divide. Now we have to get rid of that 5 because if you look over here, it does not have a number on it. This cancels. We're left with y. Negative divided by negative is a positive. And 30 positive divided by -5 is a -6. You can also write that as plus a -6. Doesn't matter, either way is correct. We know that our slope, meaning the number in the m spot because slope is m, we know that slope is 3/5, so it's 3/5. What else do we know? That should be -6. We know that our y-intercept is b, which is -6. So, intercepts, which one is the y-intercept? Well, the y-intercept needs to go in the y spot. Not only is -6 the y-intercept here as an ordered pair, but it is also here on the graph on the y-axis. 1, 2, 3, 4, 5, 6. -6. And teachers, if you want to pause for a moment, if you're doing this where everybody can see it, you can pause and talk and add a few things to it. And if you're watching this individually, students, just keep on playing the video. Okay, moving on. There's a lot here to cover. I'm just trying to see what else, where we want to go from there. So that is the y-intercept because it is on the y-axis. So I'm going to take my highlighter, and if you have your highlighter with you, I'm going to highlight y-intercept, 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 y-intercept. And I'm going to take my pink highlighter and highlight the slope. So slope, slope, slope. Guess where else my slope is? It's just right there. And that is 3/5. And to use point slope, you need a point and a slope. To write your equation in slope-intercept form, you need a slope and a y-intercept. Well, we did that. It's there, m and b. I need a point here. Do we have a point? Yes, we do. And what do I know about that point? It is x1 and y1, because it's the first point. So I can go ahead and come over here and write in my x and my y. So minus 0. Bring down the minus sign because it's in the formula. But this negative here, they didn't do you a favor. They didn't write the negative for you, so you have to write it. You have to. And this becomes a plus sign, so y plus 6 equals 3/5 x minus 0. What did I do? I had to distribute. This gives me 3/5 x, and this times this gives me 0. So now I move my 6 over, and y equals 3/5 x minus 6. Okay, and some people will say they don't want to put the minus 0. You don't have to put it at all. You can leave it like that, and then do minus 6, and then get minus 6 in your final equation. From there, let's see, what could we do? How do you find the x-intercept? Because how do I know this is the x-intercept? Well, the x-intercept, the number other than 0, is going to go here in the x spot, which means the y is always 0 for the x-intercepts. So what do we know about the y-intercepts? For the y-intercepts, the x is always 0, and that's the y-intercept. It's the y-intercept because the number other than 0 is in the y spot. And let's see here, how do I find the x-intercept? Couple of ways. It's it's easier when you start with the standard form equation. So 3x minus 5y equals 30, and you plug in y equals 0 here, because if y is 0, wherever you see y, you put 0, right? So 5 times 0 is 0, so it's almost like covering it up. And you see how you're left with 3x equals 30? What would you do? Divide by 3, and what would you get? 10. So how did I do that? Negative 5, plugged in my 0. That's 0. And now I divide by 3. And so x is 10. Now we can check this y-intercept here by plugging in 0 in the x spot. Some people use the cover-up method. So that's plugging in 0, and you're left with negative 5, y equals 30. Divide by negative 5, and what do you get? You're negative 6. So here's the work showing you what I just said. Gone. Divide by negative 5, and y is negative 6, which is why it's in the y spot. So since I highlighted the y-intercept in yellow, I'm going to do it there. And do you also notice that after you solved your point slope and finished it, and it's in slope-intercept form, but your y-intercept is right there again? And how this one says plus a negative, but that one says minus 6, and it's still the same thing. Okay, so we have 2 points right here, right? Can we use the slope formula to see if we get 3/5? Of course. So let's see, what would I do? Label x2, y2. And since this is the first point, you put 1s. This is the second point, you put 2s. He's always x, he's always y. So x1, y1, x2, y2. Now we plug it into the formula. Y2 is 0. Y1 is negative 6. So the minus sign here goes there because it's in the formula. But they did not do us a favor and write the negative for us, so you have to write both of them. Then we do x2, which is 10. Subtract off x1. That gives me a positive 6 over 10, and we reduce that. 2 goes into 6 3 times, 2 goes into 10 5, so 3/5. And it matches. So we just found m. We just found the rate of change. We just found the change in y over the change in x. Let's now look at our graph. Can we also graph the x-intercept? Yes, we can. We can go to 10. And where would we go to 10? On the x-axis. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that is my x-intercept. So I can use a straight edge. I know I can hear some of the teachers right now saying, she didn't use a straight edge. I'm sorry, y'all. Forgive me. Okay, here we go. Let me model it correctly. And put my arrows on it. And I can count my slope too. Where's my pink marker? So let's see. Up 3, rise 3, and run 1, 2, 3, 4, 5. Guess I did it right. And there's my slope. Slope there, slope there, slope there, slope there, slope there. And you should be highlighting with me. You don't have to use the exact same colors, but keep everything that is alike the same color. Okay, so let's see, what else can we do? Let's talk about domain and range real quick. What is the domain and the range of this function? Okay, well, we know that when we're talking about domain, we're going to draw vertical lines, just like my yellow and my yellow highlighter and pen. So my question is, if I wanted to see between what two numbers this function was between, meaning my domain, because these are x values, could you tell me where this stops and starts? It doesn't. It doesn't stop at all. It keeps going. So I can never say that it stops and starts. That means that every possible x value will touch or pass through this graph. See, look, touch, 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 touch. Is this one touching it? Of course, because the arrow's going to hit it. What about this one? Of course, the arrow's going to hit it. There is not one vertical line that will not touch this graph. Every vertical line, every x value touches that line. That means that the domain is all real numbers. Mr. Garrison was in our class telling us that it's really shaded in like that, but for time's sake, we just write it with the gap between it. Now, you will not see that on star. They will say all real numbers, but you still need to know what the symbol is. Now let's look at the range. So range, it's gonna look this way. And do you have a stopping and starting point for the range? Because y values have to cross the y-axis, just like x values have to cross the x-axis. So this is y, this is domain, and this is range. So can you stop? No, there's an arrow. Can you stop? No, there's an arrow. So what is the range as well? All real numbers. It's the same for both. Okay, I don't want this video to be too long, so let me hurry up. The table of values. Well, where do you get the values from? Points? Couldn't you get them from points? Yes, you could. So could we put 0, -6 here? Could we put 10, 0 here? Yes, we could. Could we get points from a graph? Of course. Well, what point is that? 1, 2, 3, 4, 5. And then 1, 2, 3, 5, -3. So 5, -3 is correct. Could you find other points to go in the table? Of course you could. We could also go to the negative. So let's do the slope to find another point. And it says I need to, if I went up 3, I'm going to go down 3. 1, 2, 3. If I went right 5, I'm going to go left 5. 1, 2, 3, 4, 5. And what point is that? 1, 2, 3, 4, -5. And what is this? 1, 2, 3, 4, 5, 6, 7, 8, 9. Make sure I counted it right. It is 3 o'clock in the morning, so make sure I counted that right. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so it looks like we are at -5, -9. Good job. Now, if I wanted to find a number between that, maybe the teacher in your class with you can show you a unique way to do that when you're practicing on your own. Okay, we have 2 boxes left, independent and dependent. So, before I do that, I'm going to talk about writing a verbal description for this problem. And I know that it says 3/5 x plus -6. What type of verbal description could I come up with for this problem? Okay, let's try this. I am going to pay 60 cents for every, or I'm going to make 60 cents for every, I don't know, what can I sell? Cookies? For every pack of cookies that I'm going to sell. Okay? Let's say package of cookies. Okay, so I'm going to make 60 cents for every package of cookies. And I had to spend initially $6 on materials. How much money am I going to make? Okay, and that's my description. Now, 0.60 is the same as 3/5. So that's why I chose to use 60 cents. And if you need help converting from a decimal to fraction or fraction to the decimal, ask the teacher in your room. And what's after that? Independent and dependent. So what depends on what? What depends on what? The total profit that I'm going to make depends on however many packages of cookies that I sell. Did you know that you could find the slope from the table? Well, all you have to do is find the change in y over the change in x. For instance, how did I move from -3 to 0? Well, you went up 3. How did I move from 5 to 10? You went up 5. So the change in y would be 3. The change in x would be 5. And look, you have your slope, 3/5. This line here is approaching positive infinity, and I didn't say that earlier, so I want to throw that in there. And this side is approaching negative infinity. And when that happens, and it's approaching both of those, you have all the numbers. Do the following equation, 4x minus 2y equals 16, on your own. Teachers are now going to walk the room as you work with your partners if they allow you to do that. And don't forget to keep the noise level down. We have prizes for you. Don't forget to sign your raffle ticket on the way out the door. Good luck. If you have any questions, make sure that you get to the teacher or teachers in your room.